My dear loving students, today we are going to learn about the lesson symmetry. After you are studying this lesson, you will be able to identify the rotational symmetry of a plane figure, find the order of rotational symmetry of a plane figure that has rotational symmetry, and find the relationship between the number of axes of bilateral symmetry and the order of rotational symmetry of a plane figure which is bilateral symmetrical. Okay, first of all, let's see a video. Okay, good. Is it beautiful? Now tell me, what do you get from that video? I think you could memorize your previous knowledge about bilateral symmetry. In there, you could see examples for bilateral symmetrical objects from the nature. What are they? They are butterflies, flowers, and leaves. Let's see what is bilateral symmetry. Do you remember? Let's see. It is possible to fold a plane figure through a line on it to get two identical parts which coincide with each other. Then it is called bilaterally symmetrical. Repeat it again. It is possible to fold a plane figure through a line on it to get two identical parts which coincide with each other. Then it is called a bilaterally symmetrical plane figure. Now here you can see few bilateral symmetrical objects from the name. First one is beetle leaf, then butterfly. Finally there is an insect. For all these figures you can see they has only one axis of symmetry. Now we move to identify the bilateral symmetrical plane figures. Let's see. In this figure you can see to get two identical parts we have to fold this figure through this broken line. That means it has only one axis of symmetry. See the second figure. To coincide the equal parts of this figure, we have to fold this in two times through this folded line. So that we can get it has two axes of symmetry. Now we move to study the number of axes of symmetry of rectilinear plane figures. Firstly, we move to types of triangles. I think you have learned 6 types of triangles. Now I here like to discuss about the types of triangles according to the length of sides. That means equilateral triangle, isosceles triangle and scalene triangle. I think you know that an equilateral triangle has 3 axes of symmetry. An isosceles triangle has 1 axis of symmetry. But a scalene triangle hasn't any axis of symmetry. Now let's move to study the number of axes of symmetry of types of quadrilaterals. Do you know the members of quadrilateral family? Who are they? They are rectangle, square, rhombus, parallelogram, trapezium and kite. According to these figures, we can identify that a square has 4 axes of symmetry, a rectangle has 2 axes of symmetry, a rhombus has 2 axes of symmetry, a kite has 1 axis of symmetry, but a trapezium and a parallelogram haven't any axis of symmetry. Then we move to learn about regular polygons with more than 4 sides. According to these figures, you can clearly identify the number of axes of symmetry of regular polygons with more than 4 sides. In here, you can see regular pentagon has 5 axes of symmetry. Regular hexagon has 6 axes of symmetry. Regular heptagon has 7 axes of symmetry. Regular octagon has 8 axes of symmetry. Regular nonagon has 9 axes of symmetry. Regular decagon has 10 axes of symmetry. Did you identify any method there or any relationship? Let's see. Accordingly to this, you can clearly identify the relationship between the number of sides of a regular polygon and the number of axes of symmetry of that regular polygon. What can you say about it? Let's get first the regular polygon with least number of sides. What is it? An equilateral triangle. An equilateral triangle has 3 sides and also it has 3 axes of symmetry. Then we move to the regular polygon with 4 sides. What is it? It is a sphere. It has 4 sides and it has 4 axes of symmetry. Then the next polygon, regular polygon with 5 sides, is regular pentagon. It has 5 sides and it has 5 axes of symmetry. According to this, you can learn that the number of sides of a regular polygon is equal to the number of axes of symmetry of that regular polygon. Are you tired, my dear students? Okay, get rest and watch this. How is it, my dear? What you can get from it? I think you could get some idea about rotational symmetry. Now let's see an activity to identify rotational symmetry of a plane figure. Now I here taken a rectangle and then I cut same size rectangle by transparent sheet. To get the center of rotation, that means first you have to select a point to rotate this figure. Now here I mark any point as simple A on the rectangle cut by transparent sheet. Then in the starting position, I put the rectangle cut by transparent sheet on the original figure. To find the rotational symmetry of this figure, first we have to find number of coincides when rotate this rectangle cut by the transparent sheet around the point A by 360 degrees in clockwise or anti-clockwise. So now we have to rotate the rectangle cut by the transparent sheet in clockwise by 90 degrees. Then you can see the position after 90 degree turn. After that, again we have to rotate this by 90 degrees in clockwise. The position after 180 degree turn, now you can see. When you are doing this activity, check how many times coincide the rectangle cut by transparent sheet with the original position. When we rotate this, we can rotate in clockwise or anti-clockwise. Now again rotate by 90 degrees in clockwise. Now you can see position after 270 degrees. After that, again rotate it by 90 degrees in clockwise. That means position after 360 degree turn. That gives the same position like starting position. Now here there are no coincides. That means number of coincides before completing one rotation is 0. Okay, now I do the same activity by getting another center of rotation. Now here I have drawn two diagonals and get the intersected point as the center of rotation. By drawing axis of symmetry, also you can get the center. The intersected point of axis of symmetry of this figure also we can get. The same point we can get. Now I again cut another same size rectangle by transparent sheet. Then I do the same activity again. In starting position, put the rectangle I cut by transparent sheet on it like coincide. Then I rotate the rectangle cut by transparent sheet clockwise by 90 degrees. Now you can see the position after 90 degree turn. After that again we can rotate it by 90 degrees in clockwise. Now you can see position after 180 degree turn. What did you see there? Did you see it? The rectangle cut by transparent sheet coincide with the original figure. That is one coincide there. Now again rotate it by 90 degrees. Now you can get position after 270 degrees. Then again you can rotate it by 90 degrees in clockwise. Then you can get position after 360 degree turn. the same position you can see like starting point. Now here you saw that number of coincides before completing one rotation is 1. Now let's see what is rotational symmetry. Rotational symmetry means when a plane figure is rotated about a fixed point in it through one complete rotation, if it coincides with the original position before completing one rotation, then it is said to have rotational symmetry. The point about which the figure is rotated is called the center of rotation. Now think about your activity. In there, when we select the intersected point of diagonals, that means intersected points of axis of symmetry as the center of rotation, that gives one coincide before completing one rotation. That means rectangle has rotational symmetry. Let's see. Rectangle has one coincide before completing one rotation. Therefore, it has a rotational symmetry. Let's see another few figures. First one is a square. The number of coincides with the original position before completing one rotation is 3. That means it has a rotational symmetry. The next figure is an equilateral triangle. The number of coincide with the original position before completing one rotation is 2. That means it has a rotational symmetry. The next figure is a heart. The number of coincides with the original position before completing one rotation is 0. That means it hasn't a rotational symmetry. The fourth figure is a special one. The number of coincide with the original position before completing one rotation is 1. That means it has a rotational symmetry. The last one is a circle. How many coincides there are? Can you count them? Can't. That means that is uncountable. The number of coincides with the original position before completing one rotation is uncountable. That means it has a rotational symmetry. Okay, are you tired? Let's see this video first. Then we move to the next part. from that video? Did you see? Did you identify the number of coincides of the regular pentagon? How many coincides are there? There are 5. When complete one rotation, it has 5 coincides. Now let's see. Order of rotational symmetry. What is this? Let's see. The number of times a figure that has rotational symmetry coincides with itself when it is rotated once about the center of rotation is called its order of rotational symmetry. Now tell me, what is the order of rotational symmetry of regular pentagon? It has 5 order of rotational symmetry. Now let us find order of rotational symmetry of a square. By doing an activity you can find this. When we rotate 90 degrees in clockwise, that coincide. Then again when we rotate by 90 degree, again coincide. Then again coincide, then again coincide. That means, what is the order of rotational symmetry of the square? It coincides with original figure in 4 times. That means order of rotational symmetry of a square is 4. Let us find order of rotational symmetry of a rectangle. Let's see. When we rotate rectangle in clockwise with original figure, it coincides with original figure in 2 times. That means order of rotational symmetry of a rectangle is 2. Let us find order of rotational symmetry of a regular hexagon. Let's see. Now here you can see the regular hexagon is coincide with its original figure in 6 times. That means order of rotational symmetry of a regular hexagon is 6. Okay. Now let's find another few order of rotational symmetry of another few plane figures. First one, an equilateral triangle. The number of coincide with original position of this figure is 3. The order of rotational symmetry also 3. The next one is a parallelogram. The number of coincide with original position of this figure is 2. That means order of rotational symmetry is 2. The next figure is rhombus. The number of coincide with original position of this figure is 2. Order of rotational symmetry is 2. The next one is regular pentagon. The number of coincides with original position of the figure of this is 5. Order of rotational symmetry is 5. The last one is the circle. The number of coincides with original position of the figure is uncountable. That means order of rotational symmetry also uncountable. Now find the relationship between number of axes of symmetry and order of rotational symmetry of a plane figure. Now observe this table. In there you have given number of axes of symmetry and order of rotational symmetry of few plane figures. See the first one, equilateral triangle. The number of axes of symmetry of it is 3. Order of rotational symmetry is 3. Does this figure have rotational symmetry? Yes. Then relationship between the number of axes of symmetry and the order of rotational symmetry is equal. Now we move to the square. Number of axes of symmetry is 4 there. Order of rotational symmetry is 4. Does this figure have rotational symmetry? Yes. The relationship between the number of axes of symmetry and the order of rotational symmetry is equal. Now we move to rectangle. Number of axes of symmetry is 2. Order of rotational symmetry also 2. Does this figure have rotational symmetry? Yes. Relationship between the number of axes of symmetry and the order of rotational symmetry is equal. The next figure is rhombus. Number of axes of symmetry is 2. Order of rotational symmetry also 2. Does this figure have rotational symmetry? Yes. Relationship between the number of axes of symmetry and the order of rotational symmetry is equal. Now we move to the parallelogram. Number of axes of symmetry is 0 there. Order of rotational symmetry is 2. Does this figure have rotational symmetry? Yes. Relationship between the number of axes of symmetry and the order of rotational symmetry is unequal. Then we move to regular pentagon. Number of axes of symmetry is 5. Order of rotational symmetry also 5. Does this figure have rotational symmetry? Yes. Relationship between the number of axes of symmetry and the order of rotational symmetry? Equal. The next one, regular hexagon. Number of axes of symmetry is 6. Order of rotational symmetry also 6. Does this figure have rotational symmetry? Yes. Relationship between the number of axes of symmetry and the order of rotational symmetry equal. The last one, regular octagon. Number of axes of symmetry is 8. Order of rotational symmetry is 8. Does this figure have rotational symmetry? Yes. Relationship between the number of axes of symmetry and the order of rotational symmetry is equal. What do you get from this table? Can you see? The plane figures with rotational symmetry always bilaterally symmetrical plane figures. But is it correct? Did you hear that? The plane figures with rotational symmetry always not bilaterally symmetrical plane figures. What is the reason? When we get parallelogram, it has rotational symmetry, but it is not a bilaterally symmetrical plane figure. Okay. From here, in this lesson, we can understand about these things. Let's see. If a geometrical plane figure which has rotational symmetry is also bilateral symmetrical, then its order of rotational symmetry is equal to the number of axes of bilateral symmetry. A figure which is not bilaterally symmetrical can have rotational symmetry. What is the example for this one? Parallelogram. The center of rotational symmetry of a bilaterally symmetrical plane figure which has rotational symmetry is the point of intersection of its axis of bilateral symmetry. Okay, this is the end of the lesson. Now I summarize it. If the order of rotational symmetry of a plane figure is 2 or more, then that figure is said to have rotational symmetry. The order of rotational symmetry of a figure that has rotational symmetry is greater than 1. The number of times a figure that has rotational symmetry coincides with itself when it is rotated once about the center of rotation is called its order of rotational symmetry. If a geometrical plane figure which has rotational symmetry is also bilaterally symmetrical, then its order of rotational symmetry is equal to the number of axes of bilateral symmetry. This is the summary of the lesson. Now we move to exercise 11.1. From that, I have selected third question. Let's see. Write down the following statements in your exercise books and mark the true statement with correct sign and the false statements with wrong sign. First one. Every bilaterally symmetrical plane figure has rotational symmetry. It is correct. Every plane figure which has rotational symmetry is also bilateral symmetrical. That is wrong. When we get parallelogram, that is not bilateral symmetrical plane figure, but it has rotational symmetry. If a bilaterally symmetrical plane figure has rotational symmetry, then the number of axes of symmetry is equal to its order of rotational symmetry. It is correct. The point of intersection of the axis of symmetry of bilaterally symmetrical plane figure which has more than one axis of symmetry is its center of rotational symmetry. That is correct. By drawing diagonals also you can get that center. A scale and triangle does not have rotational symmetry and is also not bilateral symmetrical. That is correct. This is the end of our lesson. I think all of you could get clear understand about this lesson. You can do your exercises in your textbooks to check your knowledge. Now I stopped this lesson. We will meet again in another day. Thank you and have a nice day.